Good afternoon, ladies and gentlemen of Algebra 2 Honors. We're going to go into section 9.2, which is graphing simple rational functions. And we start out with what they call an essential question. So important, essential. So how are the graphs of f of x equals a times 1 over x minus h plus k related to the graph of f of x equals 1 over x? How are those related is the question. And what we're going to do is they also have this version right here where you have, instead of a in the numerator, you have 1 over b in the denominator. And basically what they're looking at for this second version is they're trying to explain the transformation in terms of a vertical or horizontal, stretch or compression. Whereas a is addressed in terms of vertical stretch or compression, which I like to keep it in terms of. So if I find something like this over here, I like to manipulate that number so it becomes discussable in terms of a vertical or horizontal stretch. I just think it makes things less complicated. That's my experience. Okay, let's talk about this function f of x. And that's going to be equal to a times 1 over x minus h plus k. We're going to briefly discuss what these different parameters do. Okay, first thing we're going to look at is this a. What is the role of a?
That's the vertical, or it's a vertical stretch of compression. Yeah, it went to the width.
So a determines vertical stretch or in compression, right? And what I'm going to do is I'm just going to slash compression. How's that?
I like that.
Anything else that a does?
Decides if it's up or
Okay,
down.
J is saying decides if, we'll put it this way,
Positive or
if a is negative, I'll say if a is less than 0, then f of x reflects about the x-axis. Okay, next, what is the role of h?
It's axis of symmetry.
is it x-intercept?
No, it doesn't translate it like that.
Hang on a second here.
Make it move left.
Ben asked about axis of symmetry. I don't think so, but I have to think. What does h do?
Is it no x-intercept?
Shifts left or right.
Yeah,
It does that.
Okay, h will translates left and right. Or
K does.
Bryce said shifts, that's also a good word. So we'll say left slash right. Okay, and the last thing here is k.
No, it translates up and down.
It translates up and down.
K, so k translates up down,
It translates vertically.
or translates vertically, right? I'll do that, vertically or up and down. Okay, so that's really it. Now, does this have a pretty good connection with other functions we've translated and and stretched and compressed all over the place? Yeah, it should. Okay, what I'm going to do is I like this larger version of it, so I'm going to do two things. I'm going to erase this, save this. Okay, now we are to the next section right here. Okay, this is the T, analyze this, that's the official, what the state expects you to know or learn. So here, explore 1, graphing and analyzing f of x equals 1 over x. Okay, state the domain of f of x equals 1 over x. The function accepts all real numbers except what?
0.
Except 0, because division by 0 is undefined. So the function's domain is as follows: as an inequality x is less than 0 or x is greater than 0. As in set notation, x such that x cannot equal 0. I like to instead, sometimes you'll see x such that x is an element of all real numbers, but x cannot equal 0. Okay, and then finally interval notation, greater than negative infinity, less than 0, union. Greater than 0, less than infinity. So really that's it. Okay, next. We're given a couple tables here to work with, and these ones here are just represent what happens with n behavior. What happens as x gets larger and larger, and they start out with 100. So if you plug in 100 into this function, what do you get?
1/100.
1/100, which in decimalized version is going to be 0.01.
So,
Yeah.
And this next one is going to be 1/1000th,
0.001.
0.001.
Next one's going to be 0.3.
0.0001.
0. You voice crack and kind of said.
Oh, really?
Okay? And so as x approaches infinity, f of x approaches
Negative. No, 0. No, yeah, 0.
0. And now x decreases without bound, and it's a similar sort of thing, except for this one we have negative whatever this was, 0.01, negative 0.001, and the last one equals negative 0.0001. So really, that's what happens. So as x approaches negative infinity, f of x approaches 0. Okay? So that's that. So we've already said, as x approaches infinity, f of x approaches 0. As x approaches negative infinity, f of x also approaches 0. That's it. Okay, next we have another situation. We've already examined end behavior, and now we're examining as x approaches another number, not infinity, not negative infinity. In this case, we're approaching 0. You see here where it says, I'm going to try to make this a little larger. Do you see where it says, as x approaches 0, and there's this plus sign up here?
Yes, sir.
That it means as x approaches 0 from the right. So if we're going to graph this function, to graph the function looks like this, and like this. And so what they're doing, you're saying as x approaches 0 from the right, meaning this direction here, what is f of x approaching? It is approaching infinity, and we're going to kind of explain how that works, and it's explained by what happens in the table. As you divide by smaller and smaller numbers, what do we have? What's 1 divided by 0.01? It's going to be 100. If we divide it by 1/1000th, we get 1,000. If we divide by 1/10,000th, we get 10,000. And then similarly, for the negative numbers, if we go ahead, this as x approaches 0 from the left, we're going to get the same thing but negative. Negative 10,000. Now, it so happens that when we, those of you going into calculus with me or someone else in a couple years, we're going to go into these limits at a point, not limits to infinity. Yeah, we'll review limits to infinity, but we're going to go limits to a point. So we're going to go over, that's part of what calculus is.
You can kind of tell by looking at the graph.
Yeah, you can look at the graph.
The positive ones, why just goes.
No, and Jay makes a good point, and the good point, I don't think I've talked about that in this class yet. Have I talked to you about p-vang yet?
No, no, you haven't.
Haven't, right. Well, these letters represent different manifestations of functions, is what they do. So the P represents physical. So you have a physical representation of what physically happens. V represents verbal. A represents analytical, which is just like the equation, what it looks like. N is numerical, which is usually you'll see represented in a table like this. And finally, G is what? Graphical, right? And so what we're trying to do to have a better understanding, and you have an opportunity with your calculators and all the other technology available to consider these multiple things and how they connect. And when Jay is talking about just looking at the graph, he is actually doing this. As mathematicians, we do that because, and one thing that's important for us to do as mathematicians, because when you have an advanced mathematical education, as I do, what that means is in a room full of people, you're the one who understands math the best in the room. And some people want to say the smartest person in the room. I want to get there. We all have our strengths and weaknesses, right? But you are the one who understands at a high level, but the graphical is a picture of what happens. And so for most people, the picture is what helps you understand better. Okay, so, but what we're trying to do is we're trying to develop our articulation, our vocabulary, to be able to explain that well, whether to other people who are smartest people in whichever room they happen to be in, or people outside of this room. So that's why we go back and forth between this vocabulary. And that's why when you talk about translations and you say slides and moves and all that, am I cool with those kind of words? Yeah, I am. But we also understand that the mathematical word for that is translation. Okay, so this vocabulary. Okay, and then as x approaches 0 from the left, f of x approaches negative infinity. Okay, what we're going to do is go to our exercise set right here now, and let me get our papers out for us. today, what we're going to do is we'll probably do this front side of the sheet of paper. We probably won't do much on the back side today. And I want to, I'll explain, I'm going to choose people randomly for this, but I want to explain how a good way to say it. All right. So we say describe how the graph of g of x is related to the graph of f of x equals 1 over x. And so I'd start out is by saying g of x is f of x, and then you describe how you get from here 1 over x to 1 over x plus 4. What did you add with this plus 4 to this original? Yeah, I'll call somebody randomly. So I had a couple of people who said what it is, but I'll just call it.
me. Oh, of course it's Connor.
Turns it up alright.
All right. So Connor, what do you think it is? So translate it up 4 units, you say?
Yeah. I don't remember.
Oh my God, translate it up right.
It went up and right.
Fly right.
Up to my right.
It didn't go
Okay.
at all.
And so that's right. Thank you, Connor.
Yeah. There you got it.
Okay, I'm going to call somebody for number 2 here in half a minute.
It must be.
Okay, the 2, we have
Oh yeah.
J or Pete, I don't think. All right, Peyton, what do we got here?
I got g of x
G of x,
is f of x vertically stretched by a factor of 5.
f of x, vertically stretched by factor 5. By a factor of 5. Okay, any questions about that? Does that sound right?
Great.
Okay, let's look at,
Would it be point
It's multiply.
I said what? What? Right? Because it's opposite right here.
You don't want that.
Did you figure out number 4? No, nobody did that number either.
okay, here we go. Okay, number 3. Be Bryce.
Oh my God.
That way, right.
I took it in report.
Okay, Bryce?
I got G of X is FX translated left per unit.
G of X is f of x. Translated, you say left?
Yes, you said left, right, Bryce? That's what you said, right? Yes. Opposite. Maybe. Steel Bryce.
Okay, good. Good job. Everybody agree with Bryce on that one? Yeah, this is the one that can struggle. I had a student who got picked for this one, 7th period. It was a bit of a struggle.
Where you at? That way. It's up horizontal. Horizontal and. No, is this one long line?
I know it's reflected across the axis.
This one's vertical, correct?
It's reflected across x-axis, but I
Okay.
don't know what the point was.
I want to go ahead and just, I want to unbundle, because I hear some consternation, some discussion going on. What happens is if we take 1 divided by 0.1, what is that going to be equal to?
Less than 10. 0.0. Yeah, 10.
10. And I'm going to explain why that is, because if we have 1 and we divide that by 1/10, what is that the same as? It's multiplied by the reciprocal, right?
It's 10.
1 times 10 over 1, see? Which equals 10. So what this is going to be equal to is 10 times 1 over x, or 10 over x. That's what it's going to end up being. You see that?
So it would be,
So anyway, I want to call on somebody for this here in a minute. I don't know if that's helpful to those who are afraid of being called. Was that helpful to people who are afraid of being called?
I'm not afraid to be called on, so I don't know.
okay, I think I know the answer to it. And if I don't know the answer to it, then it's
Huh?
Yeah.
I have here like is.
Okay, let's go ahead. This one we got.
Let's go Benny Z. I picked you again.
No, glitch, big glitch.
Yes!
Big glitch.
Benny Z. Benny Z. Okay, Benny Z. What do we got?
I'm gonna go with horizontal stretch. I don't know.
So G of X is
Oh, f of x. Vertically compressed.
times 10 does what? Let's see, we get this. Let me show you.
Stretched.
See, if we have 0, 1, and 2, look at this. Here we have x, f of x.
I don't like that one.
And now, okay, so we have 0, this is undefined, right?
Right.
If we have 1, what's 1? This is going to be, that's going to be 1 over x, right? If we plug in 1, what do we get?
10.
1. Okay, if we plug in 2, what do we get? 1/2. Okay, now we go to, instead, we go to x, g of x, and here's g of x, right?
Right.
We plug in 0, this still is undefined, right? If we plug in 1, what do we get?
10.
We get 10. If we plug in 2, what do we get?
20.
20. So what is this thing doing? What is happening? It's 1 here and it's 10 here. What kind of thing is that?
Vertical. It's getting bigger.
Yeah, so
This is coming off your.
it's a compression.
This one here doesn't look right. This one here somehow doesn't look right. This is going to be 5, right?
Oh, yeah.
Yeah.
Because it's 1/2 times 10. This will be 5.
Yeah, I didn't see that one.
Yeah, I didn't see it. So g of x is f of x vertically what? Stretched
Reflected.
by a factor of
10.
10. Okay? I'll call somebody to do number 5.
Hey,
a short period of time
So that one's vertically stretched by 10?
by a factor of
Or
10.
yeah, by a factor of 10.
I have geovet.
I'll have to do it.
What about number 7? I said reflected across x-axis. That's fine. Hopefully I get yours. Hey, are you finished?
Okay, 5.
Where's the meaning?
Whoa.
Who is it? Yeah.
Oh, it was
But I don't know where to go.
Geez, messed up.
Big
Oh
one.
my God.
Mark it on this.
Dang.
Everybody call me.
I'm gonna get over to you.
Okay, Marcus, what do you got here?
G of x is f of x, translated down 7 units.
G of x is f of x, translated down 7 units.
But we have the.
Stop throwing stuff. Get wet. Get wet.
Oh, yeah, Mark,
Can't throw it.
Okay, anything to add here for that one? No. Okay,
Boy.
I'll choose somebody else here.
we can get through all of them before today.
Yeah, 1 through 8, yeah, we should get 1 through 8. And that'll leave us a good clean break to start on number 9 tomorrow.
(0.1) reflected about the x-axis.
Vertical stretch?
No,
Vertically
no,
compressed.
no.
It's compressed. Keep going. What do you get from?
That's actually not right.
I thought the fourth
That's not right.
Did you get it?
Is number 7, guys, is that vertically,
Vertical
compressed,
compressed.
but,
yeah.
You said vertical compressed by. You said negative?
You left it there.
Okay,
0.1, you can't have a negative factor.
Yeah.
next.
Negative causes.
Yeah.
Oh, yeah, Kim.
I think Kim-
Yeah, just think about it.
Kim seems pretty happy with it.
Okay, good.
All right.
She's a bitch.
G of x is f of x, translated to the right by 8.
8 what?
Units.
Right. And I noticed that the way of explaining it has varied a little bit between the students.
Yeah.
Does that matter that much?
Number 8.
Okay,
Annie, you better just hope you get this next one.
No, number 8.
You do.
we'll see, we'll work, whatever it is, we'll work with it, we'll get through this, don't worry about it.
Dan doesn't even know number 8?
Yeah, I know he doesn't. He's lying. He's just coming up.
Here, I get to what it is.
He's lying.
Yes, it's along the way.
As long as I get my 10 points.
Yeah, okay.
Because it's less than 1.
All right, next. Be Addie.
You're just. I mean, I sound like a rat.
That's it, I'm glad you don't know this, right? I'm glad to think, okay, what do you have?
I have G of x is f of x, reflected across the x.
Is f of x reflected, let me go ahead and rewrite that. Is f of x reflected across the x-axis? The x-axis, okay, what, anything else?
And I have vertically compressed by a factor of 0.1.
And vertically compressed by a factor of 0.1.
Yes.
a factor of 0.1.
Yeah.
0.1, right? That's a period right there, guys. Hey, but that's kind of confusing looking. I'm just going to erase that as a point right there. Very good. That's what that is. Okay. Good. And Jay, well, we know what happens to you on number 8, don't we, Jay?
I got it. I get it correct, that's what happens.
You get it correct, right?
No, he gets it wrong.
You're
You're willing to bear the burden.
I'm confident.
Confidence, good, I like that. All right, what do we got, Jay?
Okay. So I said g of x is f of x, vertically compressed by a factor of 3 and reflected about the x-axis.
Vertically compressed. I'm not seeing it that way. Hang on a second.
Actually, it might be stretched, actually.
Yeah, you got it wrong.
Or I got it straight, yeah.
I got it straight.
Because what I got here is like,
I got straight.
I got something in between.
I got this
Oh, wow. Here, vertically,
compressed.
That's not what I get.
that's what I got.
I got compressed.
Oh, so it was compressed.
By,
By a factor of 1/3
yeah. And then what else you say?
and reflected about the x-axis.
And reflected about the x-axis.
And
Let's go to the back. Honor that voice crack.
And tomorrow we're going to go ahead and start on number 9. So we'll just leave it there today. Thank you. We ought to be good.